Spherical capacitor consists of two spherical conducting shells, and the inner shell has a radius R1 and the outer shell has a radius R2. Then how do we determine capacitance of this capacitor? We have the general formula that capacitance is given by Q over U, where U is the voltage between the spherical shells. So to find capacitance, first we need to find the relation between voltage and the charge on one capacitor, okay, on one plate of a capacitor. It's very easy because U is given by the following formula, E dr, where this is the scalar product of these two vectors. E is the electromagnetic field inside a capacitor. For example, at any point, for example, I can take this point. So you see, to find potential difference, first of all, you need to know electric field strength inside a capacitor. Since this capacitor has spherical symmetry, we can use Gauss law. According to the Gauss law, we should choose such a surface that on that surface electric field strength should be constant. Now, for example, if we want to find electric field strength at that point, then we need to choose our volume in the following way. So in this way. Then electric field strength at this point has a direction which is shown in the figure in this diagram, and it is the same at any point of this surface. Consider that the radius of this surface is just r. Okay. Then, according to the Gauss law, the flux of according to the Gauss law, flux over a closed surface, which is E ds, equals 4 pi k q enclosed, 4 pi k q enclosed. So this is the charge inside the sphere. So only the inner plate is inside the sphere. Then we need to take the charge on that sphere, right? It is just q. Then this vector, ds vector, it has a magnitude which is just the surface element and has a direction which is always perpendicular to the surface and goes outward. So that's why direction of ds at this point goes like this. So this is ds vector and this one is E vector. So that's why the angle between them is just 0, right? So that's why the scalar product, which is E magnitude of the first vector multiplied magnitude of the second vector multiplied cosine alpha, where alpha is the angle between them, which is 0, equals 4 pi k q, which is so the cosine 0 is just 1, right? And since electric field strength on that surface is constant, we can take this E out of the integral notation, and if you integrate ds, you will just get s, right? And the surface area of a sphere is just 4 pi r square. So E multiplied 4 pi r square gives you q over epsilon 0, right? we substituted 1 over 4 pi epsilon 0 instead of k. Then electric field strength E, E equals k q over r square, or just 1 over 4 pi epsilon 0 multiplied q over r square. Using the relationship between voltage and electric field strength, U equals E dr, now we can find the potential difference, right? So E and dr has the same direction, so that's why again the angle between them is cosine 0, which is 1. So I can write it just E multiplied dr, and integration goes from r1 to r2. E is given by, well, 1 over 4 pi epsilon 0 q over r square multiplied dr. So q and epsilon 0, they are constant variables. So that's why we just need to integrate 1 over r square, right? And it's just 1 minus 1 over r. Then we get q over 4 pi epsilon 0 minus 1 over r, and the integration goes from r1 to r2. Now if you simplify it further, you get q over 4 pi epsilon 0 multiplied r2 minus r1 divided by r1 r2. Then capacitance C is given by this formula, right? Q over U. So now let's calculate it. Q divided by U, it is 4, so Q R2 minus R1, well, multiplied, here we have 4 pi epsilon 0 multiplied R1 R2, and it is, so cancelling Q, we get 4 pi epsilon 0 multiplied R1 R2 divided by R2 minus R1. So this is the capacitance of a spherical capacitor, and it only depends to the radii of inner and outer shells.